Hi, my name's Brian Arders, and today I'll be discussing fiberglass. Fiberglass is a widely used material in engineering and manufacturing. Fiberglass is made from very fine fibers of glass, which comes primarily from silica being a ceramic material. While glass itself is brittle, when it is formed into thin fibers and combined with other materials, it becomes strong, lightweight, and very versatile. In this presentation, I will explain how fiberglass is made, including the key manufacturing processes, and then show how it is used in real-world products. What is fiberglass? Fiberglass is most commonly used as a reinforcement material in composite structures, meaning it is combined with another material, which is usually a polymer resin, to improve its strength and durability. In this type of material, the glass fibers provide strength and stiffness, while the resin holds everything together and helps distribute loads. This combination allows fiberglass to be used in applications where materials need to be strong, lightweight, and resistant to environmental damage. Understanding this role will help explain why the manufacturing process is so important. The main ingredient used to make fiberglass is silica sand, which is primarily silicon dioxide. This is the same basic material used to make glass. Other materials are added to improve the properties of the final product. These other materials include limestone, which helps with its durability, and soda ash, which lowers the melting point of the mixture. These raw materials are carefully measured and combined before processing. This step is important because the composition of the mixture affects the strength, flexibility, and overall quality of the fiberglass. After the raw materials are prepared, they are fed into a furnace where they're heated to extremely high temperatures, typically between 2500 and 2900 degrees Fahrenheit. At these temperatures, the materials melt and form a thick liquid known as molten glass. During this process, impurities are removed and the mixture becomes more uniform. This is important because any inconsistencies in the molten glass can affect the quality of the fibers later on. This melting stage is a key part of the manufacturing process because it transforms the raw mineral materials into a form that can be shaped into fibers. This process is consistent with standard glass manufacturing methods described in materials science literature, including sources such as Materials Science and Engineering by Callister and Rethwich. Once the glass is fully melted, it moves to the fiber formation stage. In this step, the molten glass is pushed through very small holes in a device called a spinneret. As the glass passes through these tiny openings, it forms extremely thin strands or fibers. These fibers are much thinner than a human hair. As soon as the fibers are formed, they are rapidly cooled to solidify their shape. The thickness of the fibers can be carefully controlled during this process, which affects the strength and flexibility of the final material. After the fibers are formed, they are coated with a protective chemical layer known as sizing. This coating helps protect the fibers from damage during handling and improves their ability to bond with other materials later. The fibers are then gathered in together into strands and wound onto spools. These strands can be used directly or further processed into different forms, such as woven fabrics or mats. Fiberglass becomes most useful when it is combined with a polymer resin to form what is called a composite material. In this type of material, the glass fibers act as the reinforcement, providing strength and stiffness. The resin acts as the matrix, which holds the fibers together and helps transfer loads between them. This combination allows the material to handle forces more effectively than either material could on its own. This structure, shown in the diagram, is what gives fiberglass composites their strength, durability, and lightweight properties. Once the fiberglass and resin are combined conceptually as a composite, different manufacturing methods are used to shape them into final products. One common method is hand layup, where layers of fiberglass are placed into a mold and resin is applied manually, as shown in this diagram. Another method is resin infusion, where resin is drawn through the fibers using vacuum pressure for more even distribution. Compression molding can also be used, where heat and pressure are applied to shape the material. These processes allow manufacturers to create strong and complex fiberglass parts. One common use of fiberglass is in boat hulls. Fiberglass is ideal for this application because it is lightweight, strong, and highly resistant to corrosion from water. In this case, layers of fiberglass material are shaped into the form of a boat and combined with resin to create a solid, durable structure. This allows manufacturers to produce boats that are both strong and relatively easy to maintain. Another common application of fiberglass is in insulation. Fiberglass insulation is made by trapping air within a network of fine glass fibers. This trapped air reduces heat transfer, making fiberglass an effective thermal insulator. It is widely used in buildings to improve energy efficiency and maintain indoor temperatures. This is a good example of how the same material can be used in very different ways depending on how it is processed. Fiberglass is widely used because it offers several important advantages. It is lightweight, which makes it easy to transport and install. It is also strong for its weight, meaning it can provide structural support without adding much mass. In addition, fiberglass is resistant to corrosion and does not conduct electricity, making it useful in harsh environments and electrical applications. In conclusion, fiberglass is a versatile material made from glass fibers derived from silica, a ceramic material. Through processes such as melting, fiber formation, and composite fabrication, it can be transformed into strong and lightweight products used in many industries. The information in this presentation was supported by materials science sources, including Materials Science and Engineering, an introduction by Callister and Rethwich, which provides detailed explanations of glass production and composite manufacturing processes. As a disclaimer, I did use AI in this assignment. I used ChatGPT to help write the script and compile information about fiberglass and its production and manufacturing. I found it to be a very useful tool in doing those things and aided in my understanding of certain things. Thank you for watching and have a great day.